we are going to discuss two topics here, that is the 𝐂𝐀𝐈𝐏𝐄𝐄 experiment and short-lived halogens that was recently in use. So what is this 𝐂𝐂𝐈𝐏? We will move on to the 𝐂𝐂𝐈𝐏𝐿 experiment. So what is this 𝐂𝐂𝐈𝐏𝐿 experiment? So this 𝐂𝐂𝐈𝐏𝐿 experiment is nothing but a recent exercise or experiment that has been brought by IITM, Indian Institute of Tropical Meteorology, in order to enhance the precipitation. The 𝐂𝐂𝐈𝐏𝐿, the abbreviation of 𝐂𝐂𝐈𝐏𝐿 itself goes like this: Cloud Aerosol Interactions and Precipitation Enhancement Experiment, CAIPEEX. So this is what the 𝐂𝐂𝐈𝐏𝐿 experiment is. It is a method that has been used to increase the precipitation in a particular region. So yes, so what does this 𝐂𝐂𝐈𝐏𝐿 experiment do? So we have all come across this term called as cloud seeding. So it is nothing but an innovative method to increase the level of precipitation that a particular region receives. So how does this work? How does cloud seeding work? We all know that clouds contain water vapor, and this water vapor has to condense in some particle, has to come together, and then only it has to fall down as any forms of precipitation depending on the area where it condenses. It can come as snowfall, it can come as hailstorm, it can also come as regular rainfall. So depending on the area where it condenses, the form of precipitation also changes. So in order to condense all these water vapor to condense, we need something called as a base, or otherwise known as the hygroscopic nuclei, that attracts all these vapor together, and when this gets large enough, it falls down as rain. So this 𝐂𝐂𝐈𝐏𝐿 experiment and any other cloud seeding experiment you take, it tries to increase the amount of hygroscopic nuclei in the clouds. So this is what cloud seeding is, and basically cloud seeding has three types of issues. It's three types of in three ways cloud seeding can be done, that is static, dynamic and hygroscopic cloud seeding. So static is nothing but it is the use of silver iodide for increasing the precipitation. They use silver iodide as a condensation nuclei, and in dynamic, the process, the vertical air currents within the clouds is changed, and it also uses silver iodide. But in comparison, static and dynamic, static is well versed, or you can use it like most of the times is mostly used, static only is mostly used rather than dynamic, because it has certain issues, because altering the vertical currents in air and all, it takes a lot, it is a tedious process. So these two are there, static and dynamic, and alongside there is also this hygroscopic cloud seeding, that is, it tries to increase the hygroscopic materials in the clouds. So these hygroscopic materials, they act as condensation nuclei, they act as basis for the water vapor to condense and then to fall down as any form of precipitation for that matter. So what are the elements that are used as hygroscopic nuclei, or what are the elements that are used in cloud seeding? So basically the most used one is silver iodide. Silver iodide is being used. We use dry ice, solid carbon dioxide is used. We use various salts, chloride salts, we use calcium chloride salts, we use all these stuffs, potassium iodide, all these salts are being used to act as hygroscopic nuclei, and these are the elements that are being used. So yes, this is what the 𝐂𝐂𝐈𝐏𝐿 experiment and cloud seeding is. And now the 𝐂𝐂𝐈𝐏𝐿 experiment has said it has released a report that says how well is cloud seeding working in India. It studied a particular place known as Solapur in Maharashtra, and it said there are chances to increase rainfall up to 18% in a given area with cloud seeding, and at present day it costs around 18 paise for 1 liter of rainfall. But with the use of indigenous technologies and all these indigenous methods, we can reduce this by 50%. That is, 1 liter of rainfall can be gained by 9 paise by using 9 paise. So yes, this is what the report has said. And one important thing to be noted here is that this study, it portrays that not all cloud seeding cannot be done in every clouds. When it is done correctly, in 20 to 25% of cumulus clouds can give us sufficient rainfall. So one point to be remembered is it cannot be done in every clouds. It will not yield best results in every clouds. 20 to 25% of cumulus clouds will give us very sufficient results, not very good results, but yes, sufficient results will be given. So this is what cloud seeding and 𝐂𝐾𝐈𝐿 experiment is. So yes, moving on to the next topic, that is short-lived halogens. So recently, short-lived study has been released regarding the short-lived halogens. Before getting into the study, we'll just see what are halogens. Halogens are nothing but a group of non-metallic elements, that is, we have this all these things that end in ine. You take chlorine, you take bromine, you take iodine. So all these things that end in ine, astine. So all these things that end in ine are a group of, there are 6 non-metallic minerals such as iodine, tessarine, astine, all these stuff, bromine, chlorine and all. These are all called as halogen because they are salt generating. Halo means we all know salt. Gen means something that is produced or that is being generated. So halogens are salt generating. So these halogens you take, these are used in various places. These are used in swimming pools, these are used in electrical appliances, these are used as cleaning agents, and all these things happen. What does the recent study say? The recent study says that 8 to 10% of global cooling, that is reducing the impacts of global warming, is attributed to these halogens. So how does this work? So what this particular, actually it does a good thing also, bad things also, but the good thing outweighs the bad things. What it does is that it destroys ozone. All these halogens, they go up, they destroy this ozone in the sense they have this good ozone, bad ozone, right? That bad ozone is getting destroyed or being depleted by these halogens. This is the good side, and on the other side, there are 3 ill effects. There are 3 ill effects that these halogens do. One, it increases the lifespan of CH4, that is methane. It increases the lifespan of methane by destroying hydroxyl radicals that affect or that attack methane. So this is the one bad thing that it does. The other bad thing it does is that it increases the amount of water vapor in the clouds. We all know water vapor is one of the major contributors, or one of the major greenhouse gas, and one of the major contributors of global warming. So what it does is that it also increases the water vapor content in the atmosphere. And the third thing that it does is that it reduces the aerosol particles in the atmosphere. So we all know aerosols, they play a very big role in reflecting the sunlight back. When these aerosols are very low, sunlight will not be reflected back into the space, but it will come back into the into the earth's surface. So these are the 3 things that it does, 3 bad things that it does, and the one good thing, that is the destruction of tropospheric ozone. So but when you weigh this scale, this one thing outweighs all the 3 things that it does. So this is what short-lived halogens is, and there are also similar questions that have been asked earlier regarding all these chemical compounds and all these stuff. Yes, thank you.